One, two, one, two. Test, test. Est-ce que tu m'entends, Olivier? Can you hear me? Can you hear me? One, two. Okay. So thank you for being here for the last part of Hashing the Mining Industry. We still have 3 talks this afternoon. The first one is going to be by Gianluca, coming to us from Italy. And then we'll have Philip coming to us for this gridless. And finishing the day, Mags. As you saw, the schedule is somewhat dynamic, so I'm trying to see how long each talk will last, but the expectation is that we should be over about around 7 p.m. But yeah, let's start with Gianluca with Think Smart Mining. So I'm just gonna do one final check from Roxy if the sound is okay. Yes, it is okay. So yeah, you can go.
Okay, thank you very much, guys. I'm here from Italy, and I'm here to talking you about what mean to build a mining operation. And we travel about my experience that was to build the first hydroelectric mining farm in Italy. And during this work, I keep push to find a solution to make the mining operation smart. I mean, in technical side, not software side. Okay. So, what you learn here, how to make a smart choice, because we before to start build a mining farm, we need to take care about some technical aspect. For example, about source, about cooling, and other things. And in this way, optimizing the hardware operation cost. At the end of the day, the concept is to consider Bitcoin mining as a resource. So not only think to get the most possible Bitcoin mined, but thinking about how to do this job. My experience, I'm a chemist, industrial chemist in the pollution field. I work for a big company in Italy, like Eni, for example. My job was to find on the field the pollution in ground, in water, in air. And another part of my life, take work on motorsport. I'm a mechatronic, so this is the reason why I love to make. I'm a maker. I know something about electric side, electronic side, chemist side, and in a vehicle engine you can find all these things. And I use these skills. I start mining in 2013, and then I'm used my my skills to working on cooling solution and other things you need to running a mining farm, the concrete part of this field. In cooling, I developed also some oil immersion systems specific for FPGA, because as the other teacher, I think, taught you, there is a history before the ASICs. FPGA is used today to control a miner in control board or to project a new ASIC. When you need to make R&D on the chip side of the miner, you need to use an FPGA to simulate the design inside the chips. And then I start to work in my own mining farm. It's an hydroelectric mining farm in the north of Italy. Was the first or one of the first. And I worked in until 2022. Then I left the company and keep focused on heat repurposing, thanks to the cooling solution knowledge, because you can just change the word from cooling to heating. Then I want to start with the speech, talking about the mining before large scale mining, because I think all this course is about large scale mining. And what I mean for large scale mining, I mean industry, okay? And before ASIC was born around 2012. This is the first ASIC chip you can see run. Is just like an USB stick. I never got in my hand one of these, but when I start, when I heard first time the Bitcoin war, I read the white paper and then I ordered one of this. This Butterfly Labs, named Jalapeno, was the first publicly known ASIC into the market. And I have a little present for you. This is the box, and this is the first ASIC mining. It's a piece of history. Yeah, you can feel. The interesting point.
Find a way.
Yeah.
Cool. 22.
Wow. Seems you love it.
Crazy.
It's not profitable. Yeah. The interesting point about this concept, about this market, is I wait at least 10 months, 1 year to get shipped this ASIC. It's the same of today. Nothing changed. This is an important point. I will go that in the hardware signal, the next slides, but it's a very interesting things. Produce, develop, and order and get the hardware was a problem more than 10 years ago, like today. The first large miner, I use this word, large miner, was released by Buchanan. This is the Avalon 1, and this is the first large modular miner. Was just before the Bitmain revolution. The Bitmain revolution start when Bitmain produced their first ASIC chip. I use this graph for two things. First things is usually people interested in mining, thinking about ASICs mining or industrial mining, was born with Bitmain. Bitmain start mining. No, it's not true, because there's a lot of company try to produce the first ASIC years before Bitmain, you can see here in the yellow line, first Canon, and the white line histogram is the first node Butterfly Labs, and the piece you can see here. Yeah. And now after at least 1 year, first Bitmain. Another purpose of this graph that I use in the future slides is you can see on the epsilon, yeah, coordinate, is the efficiency of mining. This graph arrived just to 2020. It's not since until today. This is S19 Pro. Okay. But you can see in the time the new chips released always have less consumption to do the same hash rate. Okay. And this is just until 2020. So, concept. I use this word, small ASIC miner, okay, until 2012, 2013. As you see, Butterfly Bitfountain is the USB stick producer, and Isis Isaac, okay. And then multiple ASIC miners, so more than one ASIC into the miner. And from 2013, tens of company or R&D labs try to produce an efficient chip for Bitcoin mining. As you see, Butterfly Labs, Canaan, Cointera. The first big ASIC that I work on too was Cointera, Terraminer 4. And I remember they run 2 terahash maximum, consuming 2.5 kilowatt. Then Bitfury is a Holland company, one of the most important company in mining until 2018, and was the biggest farm too before Bitmain in all over the world. Then Bitmain, InnoSilicon, you know these names, I think Spondulis, now is, as you know, Blockstone, okay, and more. The industrial miners era, or the S9 era, coming when Bitmain produced this chip, because this chip was very efficient, but there were not a big difference between this chip and another chip of this year. But the most important difference will be Bitmain built an R&D systems, and there is a lot of people in China, you know, available to work for less money than in the United States, for example, and then become the biggest. As I told you, biggest farms was in Holland and Iceland. You hear for sure Genesis Mining. It's a very famous name in mining. It's in Iceland and more before that. And in 2014, China Mobile is a mobile company, nothing to do with Bitcoin, but start build the biggest data center in China. So with an agreement with Bitmain, in 2016, Bitmain start to mine into this data center. So this will change all the world of mining. And the next year, in 2017, they patent to the new S9 miners, and they become the biggest. In the same time, the same year, 2017, okay, a particular way to mine was born in China. I mean hydroelectric. And in the Sichuan region of China, I think the teacher before me talked a lot about no, okay, but I don't know. This is a region with a lot of rivers, and there is a lot of water, and there's a lot of hydroelectric plants, and so I will show you. This is one of the best way to make a mining farm. So this is another milestone in the mining industrial history. In 3 years, so you can see this graph is about early in 2020. Okay, China became the around 40% of mining of all over the world, and you can see Xinjiang, the most of power in the China mobile data center, and the second one was Sichuan. Okay, this is the situation, you know, before the mining ban. Okay, this is the reason I use this picture from 2020. Okay, and here you can see the power of Bitmain, because they produce hardware in China, then made mining farm. Okay, and that's it. They become the most important company in the mining industry. And this picture is a picture of me. No, I'm joking. but it's similar of my life in mining, because when you run a mining farm, especially in a related mining farm, where the turbines can switch down or switch up, or a lot of other things. And most of time I sleep close to the turbine. Okay, I don't want to give here a picture of me naked, but okay, this is the concept. Okay, why hydroelectric? Okay, why hydroelectric? Because there's a large amount of water. You know, a large amount of water mean a good way to cool the hardware. Okay, and another important point about Sichuan, or in general hydroelectric plants and other source. Okay, the direct connection to the power source, the biggest problem, because when you try to run a mining operation, there is two ways. The easiest, you must to have a lot of money, okay, and in the other way, you don't have money, you just want to grow with your mining operation. And if you use the grid power, you take power from the grid, you must pay the bill every month. And if you have some problem, economical problem, and you can't to pay the bill, the power switch off. And so is the worst situation you can find in mining. If you running directly connected to the power source, you can make agreement with the owner of the power plants, for example, and it's just like my experience. Okay, when I start the mining farm, the first day we got only 10 kilowatts. Okay, and Bitcoin is low priced, and okay, no problem. I talk with the owner of the plants, and this he told me, okay, no problem, guy. You can pay in 6 months. Okay, so the bills problem. Okay, I think this is one of the reason give this morning say the new way for big mining company is to become a power generator too. Okay. And another point is 24-hour energy. 24-hour energy is one of the most important thing to get profitable our mining operation. Okay, in all kind of mine. Okay. I use this visual logo because I think this is the three most important concept to make smart our mining. Okay, in this way you have cheap mining, both for energy price, because usually hydroelectric is one of the lowest energy price. Okay, cheap also for cooling, because cooling is a cost, and also environmental friendly. Okay. Okay, so let's start to go there. And what you need to build a smart mining operation, there is a list of concept, and I will go depth in all of that. Okay. Now the first thing is the power source. Okay, power source. There's a lot of kinds of renewable source for mining. Okay, and every kind of source have the trade-off. Okay, here you can see a table of every kind of source we can choose, and you can see the uptime. Uptime is like the uptime of the power source is another is directly connected to the energy, and solar, eolic, hydro, biogas, flaring, geothermal. Every kind of source you choose, you must be sure about to have a big uptime source. Okay, and now I'll go depth into. These are schematics of technically what you need to build a mining farm. Okay, so we are talking about not because we are talking about pools or other things. We just focus the point of the concrete building of mining farms. Okay, so every kind of source you can choose, the schematic is similar. Okay, because every kind of energy you can choose, you need to have low voltage before the ASIC. Okay, and some source produce medium voltage. So maybe you need to transform it. Okay, but the concept is this medium to low voltage coming into electrical box. And this electrical box can exchange power with the grid, or example for with some batteries. Okay, and this power source will feed the server for the management and the miner. A new things for you, I think, is PDU, is power distribution unit. This is one of the things I develop in my mining farm, because when you build and run a mining farm, you have a lot of miners, and every miner need an Ethernet connection, for example, need protection, electrical protection, I mean. And maybe we want to monitor some value about the mine. And also, you need cooling. Okay. Just for now, the power we need in mining is sum of power of each miner plus the power of cooling plus the power of CEVEX. This is a generic scan. Okay. No, I don't know if you note, there is no solar in the previous slide. There's no solar source. Not because what you need to build is different. The only things different is maybe you need an inverter to exchange 12-volt power to AC power. Okay, so this is the only technical things. But I want to go depth in solar, because most of people thinking about, oh, okay, I have a solar panel inside on the top of my rooftop, and okay, no problem. I can let's go mine. The first things to must to fix in your mind is the peak kilowatt. Doesn't mean available power. Okay, so the total solar power you can get from a photovoltaic panel is described by this bell, the red bell. Okay, so when the early in the morning, when the sun appears, we just have this power, not the peak power. And then this is the way throughout the day. So we have a bell. Okay. So for example, if you have 15 kilowatt photovoltaic panels on your rooftop, you can take 15 kilowatt just on the top of this bell, not the second before, not the second after. This is the first concept to understand. It's very easy to understand, because when the sun is in the zenith, this is the at midday usually, or 1 o'clock in the moon, you produce the maximum power. So this is the peak power. When you're going to buy or project a new photovoltaic field, who try to tell you, yes, it's 20 kilowatt. wow, okay, I go home, I have 20 kilo. No, just for 1 second. This is a very important thing. So if you want to play a solar mining activity, for example, with 2 miner, we know our power, the power needed is the sum of the power consumption of every miner, then cooling, then server. But we know we need this power for 24 hours. So there's a little bit problem with the slides because it's close. So I don't know. But
You're doing this
the right formula is P 24 hours equal to P mining multiplied by 24 hours. Okay, it's a projection problem.
Yeah,
It's not a
maybe
problem. Okay,
you export it.
so and then we know we need this power to make a profitable mining because it's 24 hours. Okay, then we can easily know how much power our mining take from the solar system to run during the day. And the expression is this yellow box. Because, and I will do an example in the next slides so we can understand better. But we know that we can run the miner not before 10 o'clock a.m. just because we don't have enough power to power on it. And the same at the end of the day. So in this case, example case, the red double arrow express the bandwidth of energy we can take from the solar system. And it's a square because on the top of this red double arrows, you can see a part of power. We don't need it. We don't need it because we need just this kilowatt. Okay? Okay. But we know the sunset will arrive. And when is night, we need the power to keep power on our mind. And how to calculate how many power we need for the night? It's easy. It's delta power, delta P for the night is the total power we need minus the power we use in the day. Okay? Mathematically, I mean, we can use the yellow box energy side to run during the day, and we can keep the red parts of the other part of the belt to take this power and put into the battery. This is the function that can say us if we can run or not. We know the total solar power coming from the sun must be equal or more than this sun. This sun, the power we use in the day and the power we will use in the night. The total powers from the sun must be equal or more than this. It's okay? Okay, now I want to give you an example to understand better. This is a website where you can, I will share you the link. You can just put here your location, okay? And this software give you a provision of how many kilowatt you can produce with a solar system in every place. Okay. Then I use this software to know how many energy we can produce with a solar system in Lugano. Okay. For example, if I buy or if I build or I got a 15 kilowatt peaks panels in Lugano, you know, from the data website, the maximum power we can take from the sun in a year is around 20,000 kilowatt. Depend on weather, because maybe for 6 months we have clouds, so it's the half, but it's just to have a prevision. This means in July, as you can see, you produce 73.3 kilowatt in a day. In December, 35. So if we know the miner we choose consume 3.3 kilowatt hours each, our power of mining is 3.3 plus 3.3. Total power is 6.6 kilowatt of mining. And we know we need in 24 hours 160 kilowatt per hour. If we think to run a smart mining operation by solar, we know we need this value in 24 hours. So the same function of the slide before. In this case, we need 9.4 kilowatt in the day, and for the night we need 100 kilowatt. But in the best day in Lugano, in the summer, in July, I can get maximum 73.3 kilowatts. So this is an impossible way to make mine. But we must have another example, because the answer is not solar is not good for mining. Because if we think we have 100 kilowatt peak on Lugano, okay, now we know the max solar power obtainable will be 132,000 kilowatt by year. That means in the same day in July, 500 kilowatt a day. So if we keep low mining with only 2 ASIC miner, in this case, we can reach the amount of power we need to run 24 hours, because we need 60 and 160 kilowatt by hour, and we will get 500. So now in the same place, but with a big difference between the mining power and the power peak of the solar system, we can run. But there's a lot of but, because it's not cheap, definitely. I don't know how much can cost 100 kilowatt hour batteries, but I think tens of thousands. Okay, a lot of more than your miner. So it's not environment friendly, because you know the pollution about the solar panel production and about the batteries pollution. So it is another point. But first of all, economically, it's very difficult to run mining under solar power. And I go that only on solar, because in all the other source it's the same. But for example, hydro or other source, you don't need battery at all. You have 24-hour energy power supply. Okay, I come back. We talked about power source selection, and the other part of systems. And then I want to talk about smart PDU and software management. Power distribution unit is one of the most important thing or trick to run a mining operation, because is something contains all the things. So you get each miner protected independently the other. You can get data from miners about consumption, about hash rate, about a lot of other things independently. And you can make graph, and you can manage all the electrical side of mining. If with no PDU, maybe if one miner have a problem, you must switch off or the protection automatically switch off a lot of miners. In this way, every miner is running his life, is isolated from the other system. You can switch off, switch on remotely, or you can program. Okay, it's like the heating system of your home. You can manage it and make programs for the rest of week, or you can switch on or switch off in particular scenario. I just finished talking about solar system, and you remember the red bell of the power. I told you you can run 2 miners from 10 o'clock in the morning, because 10 o'clock in the morning we get around 7 kilowatt from solar. But imagine to use one of these PDU, you can easily program what at 8 o'clock start just 1 miner. Then after an hour or 1 hour, 2 miners. So you can enlarge your bell operation with a smart system like this. And with GPIO connection for sensor, because you need also some temperatures from the buildings, from the containers, from the place, and you need other data like humidity, for example, or whatever you need. And you can communicate with other systems, for example, normal heating system about the inside your home, or you can communicate with other boards that do other things. Okay, it's completely open. You can connect it with all management software through the API. Okay, just on demand. And another important thing is the network switch inside. I know the cost of Cisco system, and when you going to build a big mining farm, you never mind how many it costs just to switch the cable of network. You find inside, and can be the shuffle itself. Yeah, I show you. This is a power distribution system I developed in my mining farms during my work. For example, this is the running. You have display. You can see all the line. This kind of PDU is around is 6 multiplied for 25 ampere hour. So in you can manage 6 miner and maximum 5 kilowatt each. You see here IP, because with IP is a component of your network system, is just to manage it. And here you can see it can be the shelf itself, because there is just this part in metal, but it is the shelf. Okay, so and that's it. I love it.
It's good.
Yes, it's what's one of the more important tricks to build mining.
It's very clean.
And then software management. On the top of it, you can communicate with, for example, this software is a management software that just takes data from smart PDU. This example is a Tether project. And for example, this software can communicate with PDU. Okay. Now coming back, we are going to talking about cooling system. Now open the cooling question. We know hardware gets very hot. I don't know if you never run a miner, but is something like to have a heater for your bathroom, electric heater, and chips can burn if not cooled in the right way, and that so is a cost, is a waste. Okay, so we need to understand how to manage this waste, this cost. There's a lot of cooling system. No, from the easiest is the ambient air, low cooling power. This means just the miners fans. This one have fan inside too, so no extra cost to build the cooling system. But as you can read, shorter mining life. That's it. The problem here with iron is the shorter mining life. And also big is one of the biggest problem, noise. When you want to start a mining operation in, for example, into a city or near some other human activities, I don't know if you've never been inside a mining farm, but you need yes, is a big problem, underestimated, because many projects fall down for the noise. Then adiabatic system is another kind of cooling system I developed in mining farm. Is medium cooling power and consists to use water. Okay, there is a lot of things about all the cooling system. I want to go there right now. I'm talking about higher. Okay, so here we can see the trade-off. It's good in cold areas, yes, like all the other cooling system. It's good in dry areas, very good in dry areas. So one of the most one of the place where the adiabatic system is most used is in Texas, for example, or in Arabic areas, because the panel, adiabatic panel, is just whole paper. At the end of the day, working use the energy contained in the air and take off this energy from the air thanks to the water we put on the air. What's mean? This mean this water, I put the water on the panel and this water evaporate. How this water can evaporate? With the temperature of the hot high, but must be dry because chemically speaking, the space for other water is needed into the air volume. So if you put in inlet dry air, this air have a lot of space for new humidity coming from the water and put into the pump. Is one of the low-cost cooling system you can find because you can still use the minor fans without no other fan and just put the panels between the source of cold air and the miners. Other air cool system example is Iceland. Iceland doesn't need adiabatic system of water because it's so cold. So no problem. Just big farms to have more air into the system. In Texas, adiabatic concept is used in dry cooler here. Okay, and this is an home tricks. Here we can open a big box, but this is not the moment. About home tricks, you can change the original fans of the miner with some funnels 3D printed to improve the efficiency of flow. Or you can see in the other side of the miners, this black cylinder is a particular fan with no nodes. It costs at least like miner, but you can choose to run it into your garage or something like that. Now we go to the hydrocooling. Okay, hydrocooling. This is a normal miner dashboard with the normal higher heatsink. You can see the tiny slice. Air pass through this thin slice, and this is the way to keep the heat off from the mine. The hydrocooling is another way use water, as you know, and the heatsink is called water block. The water traveling inside this box and is in contact with the chip. Okay, here you can see one of the last ant miner hydrocooling. Okay, we see here trade-off. The worst trade-off is low adaptability. I mean, if you change miner, 99% you must change your cooling system, or at least the water blocks. I know the companies, for example, like Bitmain, it is going to to get a standard for the AppSync. So the next model of cooling system from Bitmain maybe can keep working the old water block. Okay, it's good with free water, with other like other cooling system. One of the most dangerous thing is leaks, because you put water inside your mining farm, very close to your chip. Mm, eh, mm, I don't want to see water inside my miner, honestly, but some people, some guy love hydrocooling. I don't love hydrocooling, but I know can become in one of the most used cooling system because it's easy. Another trade-off is to clean. It's hard to clean. It's hard to clean. When you need to clean inside water blocks, it's very hard. It's very hard. Not cheap. Okay. You can is one of the best way to cool heat transfer speaking. Okay. One of the most power cooling system. This is the concept I just explained you by words. Cold water not touch directly the chip, but there is just a teeny metal slice between the chip and the water, and that's it. Another problem with some model, for example, this model, exactly this model, need also iron, because not the old miner, only the chips and the dashboard is protected by the water flow. Not in this case, the power supply unit is not protected. Okay, it's a classic move. Then oil cooling. Oil cooling is in the middle. Is in the middle. I spent 3 years, 4 years to develop an oil cooling because I love it. It's a strange and lovely way to keep all the heat produced by the miner. I just finished to told you that one problem of hydrocooling is not all the miner is protected, is cooled. With immersion cooling, you must be sure your miner will be live forever, at least forever. And what's the trade-off about oil cooling? It's good with free water or with groundwater, as some all the cooling system, and maybe the only worst things or bad things is to manage oil. software developer hates oil. I know in my experience, yeah. And I usually ask why. It's just oil. Then you clean your after you clean your hands. Don't want to put the hands in the oil. Okay. This is a cooling system I developed. This is one of the most loved picture for me because this is 2016 early, and this is literally a fish tank, and this is the first time I try to cool with oil. This is the first Novec oil fluid, and there is no ASIC inside. As I told you, I developed it on FPGA. Why FPGA? Because I need the most powerful source by centimeters, 4 centimeters chip, and an FPGA is one chip can hit for 500 watts in one chip. So I think that if I can cool this, I can cool everything. And that's it. This is a system for 20 FPGA and can cool, I hit 9 kilowatts. Okay, is a standard rack 19, 9 kilowatt with just 120 watt oil pump and 35 liters of oil. I know this data for you maybe is not very wow, okay, but for me, wow. Because if you take this data and look to the immersion solution you can find on the market now, they use double of oil, for example. That is a cost. Or use double or triple power of the power pump. That is another cost. You must think when you build a mining farm site, you're going to have hundreds of these pumps. So if you, for example, consume 1 megawatt in your mining farm, if you use the higher cooling system, for example, you are going to spend 10% of your bills, electricity bills, for cooling. In this way, you can use 90% less of power to cool the same hash rate. So this is the future for sure. These are schematics about oil cooling. Is two kinds of oil cooling: single phase and two phase immersion cooling. This is the simplest, and like as you see in the picture before, this is a tank with some dashboard. These are oil pumps, oil pipings, and the oil travel to all the miners, from all the miners, and then come back and come to the water exchange, oil water exchanger. And this exchanger can do other things, okay? Can exchange with other things. In my case, because I have a hydroelectric mining farm, I can take the water directly for free from the river. I don't use this part. I just use this part directly from the river. Okay. Yes, to have free water. Because if you try to run a system like this, paying for water, maybe you can pay more for water than electricity. Okay, so This is my dream. Okay, but it's a concept. Ideally, theoretically, if you build hydroelectric mining farm close to a river, you don't need to pump the water to the exchanger for the cooling. But in this case, you can just take the oil and put the serpentine into the river. I know we will not able to do this. It's just a dream, because before to do this, we need a 100% green biodegradable dielectric oil. It's not in the market now. This is the other kind of immersion cooling, is named two-phase cooling, is a little bit more difficult to manage. This oil have a low boiling point, so the miner gets up the oil boiling to a serpentine, which inside is troubled water, and then we are going to condense this water and then recondense the oil. So is the same oil continually boiling and condensed, boil, and in the same time. Okay. Imagine Bitfury. You remember Bitfury? I mentioned it before. One of the first big mining farm in the world get the first patent in immersion oil cooling in 2014. Was a engineerized container, is just like Star Wars system, and use this kind of solution, two phase, but they abandoned it a lot of years ago because they need 24-hour engineering people to work on it. So it's very extreme to manage. So this is not a good way to cool for mining. And last but not the last, because this is the best system you can think to cool mining, spray cooling. Spray cooling work better overall because you have a lot of pressure in the nozzle. This is a little explanation. You can imagine dashboard here without heat sinks, directly on the chip without heat sinks. And this system, thanks to this situation, that means with high pressure, you have a droplet, a big droplet, and there is a thin film on the top of the chip. And in this situation, I don't want to go depth a lot now, but imagine the concept is simple. The most turbulence in molecular of oil, the most heat transfer. That's it. This is a boiler for hot water already exists with ASIC inside. But another time is better than hydro, is better than immersion in classic immersion cooling, but it's very hard to manage. Coming back to the two-phase immersion system, but I think in the future can be very important, this kind of coolant. So miners. Miners. we can speak a lot about miners, but now I don't want to. Don't want to speak about the model of miner, be it main, what's miner, or other kind of company that produce miner. I just want to transmit to you the feeling I try when you run your mining farm. Because when you start to run a mining farm, you buy a ASIC. Usually the best ASIC in the market, so the most profitable and a lot of other things. But one concept must fix in your mind is the miner, to every miner profitability still go down every day, every day. One of the most mistakes is just to open a website, for example, ASIC miner value, for example, and you read, oh, wow, I buy this model of miner and I will get $50 a day. Wow, I can stop to work. But this is not true, because the value you can read is just for today. And another big mistake, when a new miners is developed, first of all, the models appear in this website. But this miner is not in the market. And the profitability you can read is fake, because nobody run this miner today. They just waiting for months. But the calculation about the profitability you can read on this website is made considered the total hash rate of today on all over the world. When this new model arrive finally into the market, and a lot of mining farms start to run it, the hash rate, the global hash rate, will increase, and so the profitability go down. So don't trust. Very thick. Okay. And so this is the situation. I want to explain you how to use this this graph that I think yesterday evening. Okay. This is the history of miner. Okay. New ASIC power on. I power on my new mining farm with new ASIC with the highest profitability possible in that moment. Then the profitability of that miner start go down, sometimes months, sometimes years, sometimes days, depend on how many new chips will be released. Okay. And then the normal way to manage the hardware in a mining farm is to order the new model before this new model is available. Usually companies that develop ASIC use your money to make R&D, because you pay year before or month before. Usually, if you want to get for the first in pole position to have the new miners, you need to buy it 1 year, 1 year and a half before from the factory. So you order, and then you're thinking to sell this Model 1. You made agreement. You sell used miner. You made agreement before, and then when the model the new model you ordered before, all right, you switch off the old and you power on the new one. And our profitability coming back up, as you can see in the graph. But we don't know. We don't know. This is a good situation for a miner manager. It's good, no problem. But in the second wave, you can see there is some problem. Some problem in shipping, for example, as I told you for this one. Okay. In shipping, in R&D, in some every kind of possible problem, but you don't receive the new model, and you must keep mining with the old model one, and profitability still go down, and maybe in this area your miners are not profitable. I remember in 2018, I ran my mining farm losing €2 for each miner every day. But we made mining in the way to keep the Bitcoin. So in 2018, the value of one Bitcoin was around 3,000, and we keep it. It's a mining mentality.
Mining math,
Yeah,
like girl.
pattern. Yeah. Okay. And then when you finally get the Model 2, you can coming back up with your profitability. And the next time, we don't know. This is the one of the most bad thing about a business plan. You must consider to have to spend a lot of time to make agreement with producer, with some small mining farm that want your used miners. There is something beyond. Okay. Okay. Now, in order to get our mining operation smart, okay, we talk about good source selection. We talked about right cooling selection. We're talking a little bit about the other question. And now we are going into the heat repurposing because it's one of the most important thing in mining right now. I think this is my opinion. Because with heat repurposing, you can exchange, you can take cost and transform it into an asset, because you produce heat. And according to the World Economic Forum, over the half of the world energy is used to generate heat. Which kind of heat mining produce is not good heat, because it is lower than 100 degrees, and this means is a low quality heat because it's not good for work. I don't want to go that now into thermodynamically side, But if you made calculation about the exergy, so the percentage of heat that you produce, the percentage you can use to make useful work is less than 10% with this heat. Okay. So this means you can't produce steam. At the end of the day, the line between the low quality and good quality heat is if you can produce steam. If you can produce steam, so more than 100 degree, okay, you can use this heat to produce another times energy. So mining is not good. Mining heat is not good for work, but is very good for heating because the power we use to run a miner is 99% converted into heat. When you want to heat something, a volume, for example, a house, a greenhouse, or a shed, industrial shed, for example, you need to make this easy calculation to understand. If you put target temperature, for example, you want to heat your house to 20 degree, and you take air from outside and 15 degree, you can execute this easy calculation to know how many kilowatt hour you need to heat this volume. This is the simplest way to understand why it's so easy to heat with a miner. You obtain cube meter multiplied by delta T, so the difference between your target and your initial temperature, multiplied by a coefficient. Okay, depend on how the walls of your house, of the shed or greenhouse is built, by something about materials, a lot of things. Now you obtain in kilocalorie by hour, you can easily convert to kilowatt by hour, and we know 99% of electrical heat become thermal heat. So that's it. It's not too easy because there is a lot of other problems we can talking about to cooling a home or a greenhouse. Is not so easy at all. But for example, there's a big difference between to heat this room starting from 0 degree or 5 or 10 ambient in the window, targeting 20 degree. Between to keep this room at 20 degree. The big difference is the time. The boiler you use in your house is very fast. This is the point. It's very fast heat. And so if you think about to heat your home with just this source, we take days, maybe weeks to reach the target temperature. This is the main difference. Okay. What's about the application patterns? You can theoretically apply in 80% of human activity. Warehouse sheds, process, preheating process, hot water, car washes, breweries. In every situation you need heat, you can use mining in a lot of way. Pizzeria, this must be right in Italian, sorry. There is no name for pizzeria in English, okay? And in agro sector or breeding, food drying, greenhouse, breeding farms, horse stables.
Are these examples that you've seen? Because I've seen all of these except for the pizzeria and the horse stables. Or
Oh,
potential
okay.
concepts.
Pizzeria, for example, you need a oven
Sorry,
to
I
make
mean,
pizza.
I've seen all of these and I talk about them in my presentation,
Yeah.
but is there actually a pizza place using it, or are these?
Yes,
separate
there's one
ideas?
here in Lugano. I don't remember since 1 hour and a half ago or two was a test. Yes, yes, but I'm not true. After the speech,
Okay, well,
I go that, but I remember one test here in Lugano because it is
the panettone.
yeah.
It's the panettone. It's like the Italian
Okay.
made with butter. It's from the bunny.
Yeah. Oh, okay. Thank you, Mattia. Okay. And about horse stables, you can use the heat to heat the stables. I remember 3 or 4 years ago, a horse company asked me, "Is possible to use uh, the waste of the animal manure, the manure, okay, coming from our horse to heat water?" I asked why, because when an horse have an injury, there is a month of therapy inside the water, hot water for the horse. It's another example. Also, wellness, sport, pools, hospital, in every kind of public infrastructure, okay? Hotels, imagine hotels at the high level of the mountains, okay? When where they have most of the year less than 0 degree. They need the heat 365 days a year. So in July and August, okay? And they can use, is one of the best place where you can think to put heat repurposing for mining. Hotels in the mountains. District heating all the building zone. I think you heard a lot about this. This is a simple scheme about heat repurposing. Is similar to oil cooling, and the concept is simple. You can use both immersion or either to produce a hot liquid, then exchange it to produce warm water, and you can use it wherever is needed, wherever. And one one important thing is the buffer tank, because usually in the last 5 years or 10, new buildings, new home buildings used to apply a buffer tank because the homes have a lot of source of heating, not just one. For example, solar thermal on the rooftop, solar, so liquid, not photovoltaic, okay, but the solar and or other source. And if you have a buffer like this at your home, you can easily add a mining heating system that just contribute to all the heating in all your buildings. These examples, this is a swimming pool, is a SPA in Manhattan, in New York. The name is Bathhouse, and since 1 hour and a half ago, they runs all their pools with as Bitcoin miner. Right now, you can go. This is Bitcoin Blue, is a Dutch company that use, as you can see, 6 ant miner to heat this flower greenhouse in Holland. And this one is another company, 21 Energy, one of the most important in this field, is Osteric, okay, and they produce this heater design. This is the heater you can see in this picture. Is higher cooled miner. Is not enough to heat all your home. Is something different to a central system, like I showed you in the slide before. But it's right now. This is not just idea. It's right now. Heat repurposing is started. So let's keep your mind. So we're talking about source selection, network power switch, management, shuffle, cooling system, when buy and sell miners, and when do a lot of things. But at the end of the day, what about environment? How mining can really do its job in the environment global problem. As you can read, the methane is responsible for 20% of the greenhouse effect. And it means the problems for the global warming potential coming from carbon dioxide, as you know, methane, and nitrous dioxide. Okay. But now we know the carbon dioxide pollution is not the most dangerous pollution, but the result of combustion of this gas is very different. If you want to see in long term, okay, as you can read, over the 100-year time is the GWP global warming potential is 28 times greater than carbon dioxide. So this means we need to produce less methane now. The most dangerous problem is methane. Last year, as you probably know, the COP28 is taking place, and they underline another time the reductions in methane emission can limit near-term warming. Here you can see one graph, one table about the result of these efforts. And these documents, namely the AER6 climate change last year, proposed to us which is the impact of the mitigation option into the environment pollution production. As you can see, this is the best ways to do our job in the next 5 years, 10 years, okay? They're speaking about 2030. Solar and wind is easy to understand, will be the best way to improve, we need to improve. But as you can read, we can use bioelectricity and geothermal, hydropower, and reduce methane. It is very important, okay? And also reduce methane and nitrous dioxide in the agriculture. I just finished to explain you. You can use, for example, biogas to run a mining operation. If you use biogas to produce electricity, you are going to produce also carbon dioxide in the atmosphere, but is less dangerous than methane. So to make a smart mining, maybe environmentally speaking, maybe the best is the biogas, because we can improve this and this. I'm now at the ending of my presentation, and I want to remember you, we start with this scam, with this, and we traveled by a lot of things around to build the mining farms to get the most profitable operation, cheapest, and environmentally friendly. The only things we don't speak until now is the decentralization. Okay, I know the other teacher talking a lot yesterday, and finally, this is another of my dream, as the mining farm with the serpentine into the river. Okay, but the most smart mining operation you can think now and for the future is heat repurposing operation inside every homes. This will this will be very hard. Maybe we will see greenhouses and shells heated by mining before homes for a lot of problem, as you can imagine. For example, to manage Bitcoin, or a technical problem, we need a good boiler, good system to sell to other people to heat their homes. But this is the most smart way to make mining. And plus, just in one word, also. That's it. I don't want to go deep into the decentralization choice, because I think you know, but just hit your home is not the smartest way overall. The smartest ways overall is no PSC, is just usually you pay bill for the gas to heat your home or other things. Now not now, but I hope, but it will be to take Bitcoin from your heating system. So I have no words more, but when I look at this picture, I I feel very bad. And that's it. Thanks.
Thank you.
You? Well, I've been understandable because I'm not rocky English people, but
Very good. Very interesting. Thank you so much, Gianluca.
thank you.
Thank you for your time. All right, guys. We got two more talks. I think we're gonna take 10 minutes, 10 minutes break, and then we move on with Philip from Gridless. Thank you, guys.